Let's talk about the sixth project. And this project is actually a really good application of data mining, because what we're doing is we're actually looking at real data. This is the result of NFL games over the past however many years. And we're using that to make predictions about future games, right? So it's kind of very vanilla, but definitely a realistic application of data science. Okay, so let's take a look. This is what we're going to learn here. Some simple specifics. You're going to learn how to read a comma separated value file into Python. This is actually really useful because a lot of times the way that you're going to get data from a application, okay, the way we get the data is somebody will mail you an Excel spreadsheet, right? And then it's up to you to somehow be able to read that. And the answer is that we can get Excel, we can tell it to export comma separated values, and then load those into Python. It works great. Okay. You're also going to learn about NumPy. NumPy is numerical Python. It is a library that's kind of designed to work with matrices and vectors and lots of other numerical types of things. I'm going to say this without exaggerating at all, that if it wasn't for NumPy, we probably wouldn't be using Python as much today, certainly not in data science. NumPy is the kind of library that really ended up putting Python on the map, okay? Something else you're going to learn, this is kind of a subtle point, it's about computer science, it's not really data science, but you're going to learn that you can have a problem and that you can actually solve it in radically different ways. And sometimes that has a profound effect on the performance. So it might be fast if you do it this way, it might be not so fast if you do it this other way. But we're going to see that the solutions aren't even similar to each other. They can be very, very different. Okay, so let's talk about the problem, right? What we're going to do is we're going to rank NFL teams. So we'll have the best NFL team, the second best NFL team, the third best NFL team, and so on. And we're going to use that to make prediction about games. So if team number 3 is going to play team number 28, then we're going to make a prediction that team number 3 is probably going to win that game, right? That's how we're going to use that. Like I said, that is classic data science, okay? So here's the first solution, right? So the first solution is this. We're going to read that comma separated value file. In fact, we'll do that for both solutions, right? But we're going to go ahead and read that. And then we're going to store it in Python in a way that's fast and easy to process. Okay. So again, this is typical when we're doing data science. A lot of times we have to get the input data and then massage it in some way so that we can actually process it in better fashion. Okay. So we're going to process it based on these questions, right? These are the questions that I know you're going to have to answer in your code. So might as well use that to design our data structures. Okay. So the first question is, I need to know all the games that Team X has played in. For example, what games has the Denver Broncos played in, okay? In particular, we're gonna wanna say, I would like to pick a random game that Team X has played, okay? So give me a random game over the last 10 years of history where the Denver Broncos have been one of the two teams, okay? The other thing that we're gonna wanna do is we're gonna have to actually go through all the games, right? Not just a random one, but all of them, so that we can make some kind of aggregate statistical or probabilistic measurement, okay? Now, here is how the first solution works, right? Once we have that data structure, then we're going to pretend that we're a very fickle football fan, right? I kind of think in terms of my sister-in-law, who's been a Chargers fan unless they lose, which is almost every week. So, she keeps moving around. But anyway, what you have is you have a favorite team, right? And the favorite team is actually a recent winner. So here's how it goes. You start with a random team. Let's say the San Diego Chargers back then. Now they're in LA. Okay? And that team then plays a game and you cheer for them. But let's say that they win. Okay? Well, good. Your favorite team won. That is definitely still your favorite team. So you'll cheer for them next week. Okay? But next week rolls around, they play some other team and they lose. And you go, oh my God, these guys are losers. I can't cheer for them anymore. So then you switch to the other team that actually won. And you just keep doing that, right? You have a favorite team. You watch them play. If they win, they stay your favorites. If they lose, they're not your favorites anymore. Now whoever won becomes your favorite, right? Now, do that 10,000 times, right? By the way, maybe you want to do it 100,000 times, okay? You simply do it enough times that you get kind of a good sense of which teams have really been your favorites, right? Historically. So you might find, for example, that the San Diego Chargers were your favorite team, say, 28 weeks, but the New England Patriots were your favorite team, let's say 150 weeks, right? And so that's how you would know that New England is probably a better team than the Chargers. Okay, so that's the idea. Okay, so that's one thing. So what do you really need to do? You're gonna have to keep track of the number of times that that a particular team is your favorite. Okay, so that's it. Okay, I do kind of want to say just I guess a hint, if you will. One of the things that I want you to do is always use the data that we have, right? So when I say actually randomly pick, play a game this week, I don't really mean play the game this week. That would be running in real time. What I mean is you got 10 years of history, you got 30 years of history. There's been a lot of games that particular your favorite team has played. Pick one of those at random. You see, that's one of the questions, right? Pick one of the teams that my current favorite team has played randomly in the past. You pick one of those games, right? And then you're going to use that to decide next week's favorite team. Okay, so yeah, that's it. That's the entire program, and you can get that working. Okay, all right. Now let's do it a second way. Okay, this is a different solution to the same problem, but different solution. And we're going to start with the same way that we started the last one, which is we're going to read this common separated file. We're going to read it into memory. All that stuff still stands. Okay, what's different is that we're no longer going to have a favorite team. Okay, instead, what we're going to do is we're going to say, okay, I actually kind of like all teams, right? But I don't like them all the same. So instead, what I'm going to have is I'm going to have a probability that each team is my favorite team, right? So think about how that comes about. In the first one, we found that we were with the Chargers, 20-something times. We were with the Patriots 150 times, right? So the probability that the Chargers are my favorite team is 25 over however many weeks we did. Patriots is 150 over however many weeks we did. So you see, last time we were counting the number of games, right? That a team was our favorite. Now what I'm saying is let's actually have a probability. Right? Let's say, what's the probability that New England, God, I hate to admit it because I'm a Broncos fan, but it might be pretty high. Okay, so that's what we'll do. All right. So here's kind of the idea. Let's say there's only 3 teams in the NFL, so it's just Denver, the New York Giants, and Dallas. Okay. So at any given time, right, we could say something like, well, the probability that we're visiting Denver, which is to say the probability that Denver is the quote favorite team that week is 50%. Okay, for the Giants it's 30%. For Dallas is 20%. Okay, so we're going to store that in a Python list. Okay, so right here, what we have is a list that tells us that the probability that we like Denver is 50%, that we like New York is 30%, and Dallas 20%. Notice that I'm actually storing the probabilities as a number between 0 and 1, right? We always say like 20%. That's not what we mean. We mean 0.2, because 20% literally means 20 out of 100. That's 20 over 100. That's 0.2. Okay, so always use probabilities that way. Forget the percentage stuff. Okay. Now I want a list. I actually don't want a dictionary, which would make more sense, right? Because I could say, oh, what is the probability of Denver, right? No, I actually want a list. There's a reason for that, and it'll become obvious in a little bit, but for now, just trust me, okay? So that means that we need to know the order in which the teams are arranged. You can do it alphabetically if you want, okay? What I suggest that you do is that you have a dictionary, right? And initially, the dictionary is empty, okay? But let's say you discover a team, right? You're reading the CSV file and you find the team. You go, oh my God, here's the team. It's Denver, right? Then that becomes team 0. The next team that you see, maybe it's the New York Giants. That becomes team 1, and so on. Okay, so that way you simply assign the numbers as you discover the teams, and then that becomes the order in which you're going to place the data in this list. Okay, it's very important that we have a good ordering of the teams. Okay, so now here are some probabilities that I want to compute based on the data that I have. Okay, so let's say that I'm currently visiting the Broncos. Okay, what's the probability that next week I still think the Broncos are the best team? What is my favorite team, right? What are the chances of that, right? I'm not going to go through the details now, but if you think about it, I can actually compute that based on the historical data, right? Because I know all the games that Denver has played. I know all the times that Denver won, right? Well, there's my probability that next week I'm going to pick Denver if I'm currently in Denver, okay? Now, the next 2 questions are actually almost the same, right? But basically it says this. Suppose we're currently visiting some other team, New York Giants. Okay? Suppose we're visiting the Giants. What is the probability that next week we'll decide that the Broncos are our favorite team? Okay? Again, how does that happen? Oh, it means that the Giants must have played the Broncos, right? Because otherwise I would have moved to the Broncos. I moved to either the Giants or some other team, right? So the Giants must have played the Broncos and the Broncos must have won. Right? So what are the chances of that? Again, I got all the games that the Giants have played. I know how many of those there are, right? And I also know how many of those involved a Broncos victory, right? And so, number of Broncos victories divided by the total number of games the Giants played. Boom, that is the answer. Okay, so that's how we can answer both of those questions, right? These are questions we'll be asking quite a bit. Okay, so now I'm going to say, and this is kind of an important notation we'll use quite a bit, and the notation that I have is this P of B comma A. Okay, and what that is, that's the probability that I'm going to decide that team B is my favorite team, even though right now my favorite team is team A. Okay, so the probability that I'm going to like the Broncos next week, given that I'm currently a New York Giants fan, is actually the probability of Denver, comma, New York Giants. That's the order in which we put them in. Okay, so let's use that. Okay, suppose that I got all those probabilities. Now, before we said that there's a 50% chance or 0.5 probability that I'm visiting Denver, or that Denver's my favorite team. There's a 0.3 probability that I'm visiting the Giants, or that the Giants are my favorite team, and a 0.2 probability that I'm visiting Dallas. Okay, so what are my probabilities that I want to stay, or I want to be in Denver, right? That Denver is my favorite team next week, and the answer is this. Okay, and so what I have is this. It's the probability that I'm currently in Denver, right, which is 0.5, times the probability that if I'm currently in Denver, I actually want to move to Denver. Okay, so that's part of it, right? Also plus 0.3, 30%. This is the probability that I'm in New York, and that, given that New York's my favorite team, I actually want to move to Denver next week, right? Plus the probability that I'm in Dallas, which is 0.2, times the probability that, given that I'm in Dallas, I actually want Denver as my favorite team next week. Okay, this may throw you a little bit for a loop. Okay, you can just trust me. Okay, you can trust me that that is the correct way to do that probability. If you've had probability class, you might want to try to think through it and go, oh yeah, absolutely. In fact, quite honestly, that's like an expected value. Okay, that's exactly what it is. And if that word doesn't mean anything to you, that phrase doesn't mean anything to you, it's a weighted average. It's the average of all those three probabilities weighted by the current probabilities of where I'm at. Okay, so that's actually what that is. Now, it turns out that that's not exactly right. Okay, the reason it's not exactly right is because all of those P, B, comma, A's, right, excuse me, are smaller than 1, right? So I have the original values, then I multiply them by something that's smaller than 1, add them all up, I might end up with something that actually the sum is smaller than 1, which means that the probability is smaller than 1. Can't do that. So the result of this is sort of a probability, okay? Not exactly a probability, okay? So there's two schools of thought. One school of thought says, just don't worry about it. It's all scale factor anyway, so just keep working, right? At the end of the day, then you have a whole bunch of numbers that you claim are probabilities. Go through those and actually scale them so they add up to 1. Okay, so it's the difference between saying 50%, 30%, 20%, and saying 5, 3, and 2. Right? It's just a scale. 5, 3, and 2 add up to 10, so you have to divide by 10 to make it come out. Probabilities add up to 1. That's what I'm talking about. Okay, so yeah, it's not really terrible. You can just do that. Okay. I would probably recommend that you scale them to 1 each time through the loop, just so you don't have to worry about it. Okay, if you print them, they look reasonable. Okay, so what's the probability we go to Denver at the next step? Like I said, we make it this thing, right, which is what we got from last time, right? And those are actually those probability that I go from some place to Denver, right? And then the probabilities that I'm actually at that place right now. That's what I'm adding up, okay? And there's kind of a big observation here, and that is that the probabilities, that I'm visiting a team right now, I made that a list. I'm actually going to use a different word. I'm going to use the word vector now, as in mathematics, okay? And the other thing I'm going to say is that the probabilities A comma B can actually be written as a matrix, okay? And if I write it as a matrix, M for matrix, also M for Markov. Yeah, I know a couple of you are math minors or math majors, so M for Markov to you too. So that's the probability of, the matrix of probabilities, okay? And it turns out that if you use the standard, the classic matrix vector multiplication, is actually doing those exact operations, right? That's why we like to write these probability matrices as a matrix and a probability vector as a vector, so that we can do matrix vector multiplication and basically get, if I have the probabilities of my favorite teams this week, I can get the probabilities of my favorite team next week, right? Guess what? I do that again the next week, the next week, the next week. I do that 10,000 times. And then the probability vector will actually converge, if I want to use the mathematical word, or just simply get closer and closer to the real probability vectors that actually give the actual rankings, right? So that's the way that we're solving this particular problem. Okay, so here's the start. You need a P is the probability vector, right? Little p for probability. And initially it's at random. You can actually do almost anything you want, okay? The only caveat is the probabilities of dot up to 1, right? So, you can't just say 0, 0, 0, 0, 0, 0. Right? That would be bad. But you could, if you wanted to, say Denver 1, everything else 0. You could do that. You could make it 1 divided by the total number of teams, which is 32. Or you could just randomly do it and then scale it so that it all adds up to 1. It doesn't matter. That's one of those really amazing things about these particular kinds of matrices that are called Markov matrices. Okay? But anyway, once you find this probability vector, then we're going to figure out P is equal to M times P. M times P is matrix vector multiplication. And that means we get a new value of P, right? And we'll get a new value of P and a new value of P and a new value of P. We just keep refining our probability vector until it gets closer and closer to the true probability vector that's kind of implied by that matrix. Okay, so in the end, P actually has the final probabilities, and now I can convert that to a ranking. How do I know if team A is ranked above team B? What's the probability that I'm with team A? If that's higher than the probability that I'm with team B, then it is ranked higher.